Hi everyone, welcome back. So before we start this session, let me tell you, today I am very happy. You already know. Okay. So yesterday GATE result came. GATE 2023 result came yesterday. And I shared with you the results. Okay. Have you seen the GATE GoClasses course enrolled students? Please understand, you already know all of them. You already know that they are in the private group. You can discuss with them. GoClasses course enrolled, complete course enrolled students. So let me tell you, this is the GATE 2023 result that we are getting. Let me just quickly tell you. So GATE 2023 result of GoClasses. If anyone asks you in any Telegram group, on any social media, if anyone asks you what is the result of GoClasses, you can tell them that in GATE 2023, from GoClasses complete course student, GoClasses complete course enrolled students, complete course enrolled students of 2023. They are from the 2023 batch of 2023 batch. Okay. So these are complete course enrolled students, all of them. And you already know their rank. You already know that we have all India rank 11, Khusit. He's already in the private Telegram group. You already know him. Okay. So Khusit, you know, all India rank 13, Anjali, she is also in the private Telegram group. You already know that she was going to top. Okay. These are, remember, these are GoClasses complete course enrolled students of 2023 batch. Okay. I am not considering in this list, I am not considering the test series enrolled students. If I consider those also, you cannot believe what kind of result we are getting, you know. But let's consider only the complete course enrolled students. So all India rank 11, Khusit, all India rank 13, Anjali, all India rank 16, Himanshu Datta, everyone knows him, all India rank 29, Sisir, all India rank 34. On 34, there are three students on all India rank 34. And there are many more. There are many more. You can check it out. Okay. So there are many more. Finally, let me tell you, you can see this. So ultimately, so far right now, at this point of time, 14 plus students, 14 plus students at this point of time. Okay. And we are getting more and more, but at this point of time, I know 14 plus students who are in this group, who are in our GoClasses private Telegram group. You can talk with them, you can discuss with them, you can ask them their strategy. Okay. So 14 plus students so far from the complete course 2023 batch, 14 plus students in top 100, in top 100, and this is still counting, remember. Okay. So we are still collecting the results of our enrolled students. So this is still counting. So this is the kind of result that we are getting this year. I am not including the test series enrolled students. Okay. This is the complete course enrolled students of 2023 batch. Okay. So this is something just I wanted to tell you. And of course, we will take interview of all of them. Okay. Every day, one to interview you will keep getting. Okay. Is there, so every day you are going to get one to interview you are going to get. So whatever interview you watch, okay, in every interview you will learn something new. You will see what is the strategy of these toppers. Okay. Khusit, Anjali, Himanshu Datta, okay, Sisir. So you will see their strategy, and from every interview you can learn something new. Okay. So you will definitely find something good from every interview. So whenever you watch an interview, please share it, please comment on it, and like it. Okay. So comment is very important. So whenever you watch an interview of all these toppers, because you are friends with them, okay, you have seen them in the private Telegram group. So whenever you see their interview on the GoClasses YouTube channel, please comment. Okay. Please comment and like and share. Okay. Now let's come back to our discussion. In this session, what we are going to do, we are going to discuss the homework 1, 2 discussion of propositional logic. Now let's see homework 1, 2 discussion. So did you solve this question? Did you solve this? This is the homework one question 2. Okay. So I am taking all the questions in which you may have doubt. Okay. So let's see homework 1 question 2. The question is saying that we have seen that for two propositional variables, if you have two propositional variables, then we have 4 rows in the truth table. Because with two propositional variable, total 4 combinations of truth values are possible. Okay. See, then if you have 3 propositional variable, then how many rows will be there in the truth table? Simple question. Now let's discuss. See, when you have two propositional variable, like let's assume you have propositional variable A, propositional variable B. Now, if you have two propositional variable, or maybe you can take P comma Q. So you have P, you have Q. Now, with the two propositional variable, how many combinations are possible? I told you that every propositional variable, because these are propositional variable, and I told you that every propositional variable has two choices. Basically, is either true or false. Okay, has two possibilities. Every propositional variable is either true, either this propositional variable is true, or this propositional variable is false. It has one of these two values. Okay, one of them. Okay, so every propositional variable has one of them. Every propositional variable has one of these two truth values. Okay, one of them. So either it will be true or it will be false. One of them it will have. Now you can notice how many combinations are there then. Very simple. Total how many combinations are possible? Very simple. You can easily see. You can do like this. Please understand, you can do like this. What you can do? See, P is possible to be false, right? Correct? P is possible to be false. So when P is false, you fix it. P is false. Now when P is false, there are two choices for Q. Either Q can be false or Q can be true. Correct? Very simple. Okay, very simple, that when P is false, because you know P is a propositional variable, Q is a propositional variable. So every propositional variable can have one of the two truth values. Okay, every propositional variable is either true or false. One of these truth values every propositional variable has. Now you can easily see that if when P is false, then Q either can be false or Q can be true. Similarly, when P is true, then again Q can be false or Q can be true. So like this, you can create the truth table very easily. Okay, so there will be total 4 combinations. I can say these are the total 4 truth value combinations. Truth value combinations. There are total 4 truth values combinations possible. Simple. Now, with 3, how many will be there? If you have 3 if you have 3 propositional variable, like these are the propositional variables. Now, how many truth value combinations are there? For three variables. Now you can easily see. Please understand that actually here P has two choices. Here P has two choices. Here Q has two choices. Here P has two choices, either true or false. Okay, Q has two choices, either true or false. So P has two choices, Q has two choices. That is the reason total they have 4 combinations. That is the reason total 4 combinations are there. Now you can easily see that if you take 3 variables, then what will happen? This P can be either true or false. This Q can be either true or false. And this R can be either true or false. Now you can easily see that there are 2 possibilities for P. Either it will be true or it will be false. There are 2 possibilities for Q. Either it will be true or it will be false. There are 2 possibilities for R. There are, I can say, 2 choices. There are 2 choices for P. There are 2 choices for Q. There are 2 choices for R. So finally, total how many choices will be there? Total how many combinations will be there? That will be 2 multiplied by 2 multiplied by 2. That is 8 combinations. Total 8 combinations are possible. Okay, you have total 8 combinations possible. Let's write them. Let's write all of them. So you can easily write like this. If you want to create the truth table, you can do like this. What you can do? How will you do? Tell me. See, either P is true or P is false. You agree? There are 2 possibilities. See, here you can put P true, so P false. So P is false. Now, when P is false, when you fix P, then how many possibilities for Q are? There are 4 that you already know. If you have 2 variables, 4 combinations are possible. So you can notice what you do. You fix P. You fix this P. We are fixing it that this is false. You are fixing it. Now you can notice there are 4 combinations possible for Q comma R that you already know. Okay. False, 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 true, true, false, and true, true. Very simple. Now again you can notice, now you fix P equal to true. Now you fix P equal to true. Again the same 4 combinations again you can write. Okay, again you can notice this q can be false. So what you do, you first you fix this. So what you can do, first you fix this, then what you do, now you fix this like this. Okay, so very easily you can create, and you can notice this will be false true, this will be false true. So like this you can create the 8 combinations. I hope this point is clear, how I am creating the 8 combinations, how I am writing the 8 combinations. Is this clear? So there are total 8 combinations possible. 8 combinations are possible. Okay, very simple. Now if you have n variables, similarly actually you can create for 4 variables. If you have p, q, r, s, there are 4 propositional variables. The similarly you can do actually something like this will happen. Please understand, with 4 variables what will happen, again 8 cases will be there when you have p false, right? Correct. So here you fix it, p you fix false. Okay, here you fix p for p true. So here you fix p true. Now you can notice, now it is very simple. Tell me, once I fix this p, how many combinations for 3 variable? Tell me, how many combinations for 3 variable? We have seen how many combinations for 3 variable. For 3 propositional variable, 8 combinations. So here all the 8 combinations you can write. Similarly, here also all the 8 combinations you can write. Isn't it very simple? So very simple that what I am saying, if you have 4 variables, 4 propositional variables, you have PQRS, then how you can create the 16 combinations are possible. Okay, 16. Why 16? Because very simple, 4 variables, 2 into 2 into 2. So that is 2 power 4. These many combinations are there. These many combinations are there. And how to create the truth table, I told you. What you do, you fix p equal to false. When you fix p equal to false, then with the 3 variables, 8 combinations are there. And when you fix p equal to true, then with the 3 variable, 8 combinations are there. Total 16 combinations we will create, and that is 2 power 4. 16, 2 into 2 into 2, because every variable, this is for p. These 2 possibilities for p, these are for s. These are for s. These are for q. These are for r. So finally your answer is 2 power 4. 2 into 2 into 2. Now tell me, if you have n variable, then what will be the answer? If you have n propositional variable, then finally what is your answer? So if you have n propositional variable, then your answer will be, you have n variables. Like let's assume these are the n variables, p1, p2, p3, and so on, pn. Let's assume these are the n variables. Now this has 2 choices. This has 2 choices. This also has 2 choices. So everyone has two choices, 2 choices. Finally, your answer will be 2 multiplied by 2 multiplied by, and so on. So from here, you can see that your answer will be 2 power n combinations possible. 2 power n truth value combinations are possible. So this is how you can understand. Okay, 2 power n truth value combinations. Truth value combinations. So 2 power n truth value combinations are possible. These many. This is your answer. So for remember, very simple. For n variables, the number, if you have n variables, if you have n propositional variables, then there will be 2 power n rows in the truth table. When you create the truth table, p1, p2, these are your variables. Pn, these are the variables. When you create the truth table, there will be 2 power n rows. Okay, every row is a combination. So that like these are, so I can say 2 power n rows will be there. Very simple. This is your answer. So this is a question that we have in the homework. Now, is it clear to everyone? Anyone has any doubt in this? Anyone has any doubt in this? Simple. Okay, this is a simple, but this is important. Okay, these things are important. Okay, because we will use them again and again. These things are useful. So anyway, this question we have seen. Now let's move on. Let's see this question, homework 1, question number 8. In homework 1, question number 8, let's see. So what the question is saying, it is known that p is true. It is known that p is true. So p is already true. Remember, this is given to you. This is given to you that p is true. Then what can we say about negation p and q? Negation p and q. So what is negation P? Negation P will be false. Negation P will be false. So it's like false and Q. Now you tell me, false and Q. False and anything is false. Correct? Remember this point we already know. We know that false and false is false. False and true is false. False and anything is false. False and anything. False and anything is a false. So here false and Q, that will be false. So what we can say about this statement? We can say that this is a false. So this is your answer. So again, very simple question. Now this is interesting. This question, let's solve it. This is homework 9 question, homework 1 question 9. It is known that P is true. Again, we know that P is true. Okay. So this is already given to you that this P is, this is given. This P is true. This is given. Now, what we can say about negation of P and Q? Negation of P and Q. First of all, what can you say about P and Q? Remember, P is true. So what can you say about true and Q? Let's see. What can you say about true and Q? What can you say? What that will be? True and Q. What that will be? Let's think about it. See, let me tell you very beautiful method. A beautiful way I am telling you. Okay, see this. See, this true is fixed. Can I say true is fixed? Can I say true is fixed? Can I say this is constant, right? This is constant. This is constant. This is a constant. This is fixed. Now true is fixed. True and Q. Let's see what we write in this box. Let's see what we are going to write in this box. Now you tell me. Now you tell me. If this Q is false, what I will write in the box? What I will write in the box? If this Q is false, then what I will write in this box? In this box, what I will write? In this box, I will write false. Okay. Now tell me, if Q is true, what I will write in this box? What I will write in this box? If Q is true. If Q is true, in this box, I will write true. Can you see in this box, I'm writing whatever Q is? Can you see in this box, I'm writing whatever Q is? In this box, ultimately what I'm writing? Ultimately, I'm writing whatever Q is. If Q is false, I'm writing false. If Q is true, I'm writing true. So whatever Q is, the same Q I am writing here. Do you agree with me? Please tell me. See, if Q is false, I'm writing false here. If Q is true, I'm writing true here. It means I'm writing Q. It means I'm writing Q as it is. So this is the way. So finally, I can say true and Q, that will be Q. This is the proof. This is a very simple proof. Now let me ask you, using this same method, can you tell me the answer of this question? Let's assume this is true, this is fixed, and this is Q. What I will write in this box? What is this equal to? Using this same method, you try. Using this same method. Again, let me try. This T is constant. Do you agree with me? That this T is constant. This true is constant. This is a constant. No one is going to change it. Okay. Now this is constant. Now you tell me. Now let's see what we write in this box. Okay. So what this is equal to? This expression. This is equal to this box. Now you tell me, if Q is true, then what I will write in this box? If Q is true, what I will write? If Q is true. True implies true is true. True implies true is true. And if Q is false, if Q is false, if Q is false, then that is false. So you can notice, can you see I am writing Q? Can you see that? I am writing Q as it is. What if Q is true? If Q is true, I'm writing true in this box. If Q is false, I'm writing false in this box. I'm writing same. I'm writing Q. So can I say that in this box, I am writing Q itself. So this is your simple answer, that this will be equal to Q. So true implies Q is Q. Let me ask you one more. What about this one? P implies false. What is the answer? Using this same method. Without taking copy pen, can you do? Okay, this one you do with copy pen. This question you solve with copy pen. With copy pen, you solve this question. What this will be? Use the same method that I am telling you. See, this is constant, right? This is constant. This is not going to change. This is constant. This is false. Now you notice P implies false. What should I write in this box? In this box, what should I write? Think about it. See. This is fixed. This is fixed. Now, if P is true, what I'm writing in this box? If P is true, what I'm writing in this box? What I'm writing in this box, if P is true? If P is true, I'm writing false. Because true implies false is false. Now, if P is false, what I'm writing in this box? If P is false, if P is false, false implies false. That is true. So now what I'm writing in this box, I'm writing true. Tell me in this box, ultimately what I'm writing. What is your observation? What I'm writing, can you notice? Can you notice? Basically, whatever P is, I'm writing its opposite. Do you agree? If P is true, I'm writing false. If P is true, I'm writing false here. If P is false, I'm writing true here. Whatever P is, I'm writing its opposite. I'm writing its opposite. So I can say that this will be negation P. So your answer will be, remember your answer will be P implies false. That is same as negation P. This is a good method, right? I hope you are liking this method. See, very just analytical. It's just pure analysis. Now, without taking copy pen, can you solve? Can you solve without taking copy pen? What is true, exclusive, or P? Don't take copy pen. Don't take copy pen. Can you solve this? True, exclusive, or P? Again, very quickly I will do. Is this clear? Very quickly. See, in this box, I want to write. If P is true, what I will write in the box? If P is true, what I will write in the box? I will write false. If P is false, what I will write in the box? If P is false, what I will write in the box? I will write true. Can you notice? In the box, I am writing the opposite of P. Can you notice? Can you notice? In the box, I am writing opposite of P. So in the box, I am writing negation P. So very simple, like this. Now, I hope you are liking this method. Very simple method, very simple method. Now tell me the answer now. Don't take copy pen. Don't take copy pen. If you take copy pen, how will I know? But yeah, you don't take copy pen. Okay. Now tell me. So now again, same. Again, this is the box. I want to find what I'm putting in this box, right? If P is true, what I'm putting in this box? If P is true, what I'm putting in this box? What should I put in the box? You tell me. If P is true, I should put true in the box because true, exclusive, or false is a true. Okay, because exclusively one of them is true, right? Exclusively one of them is true. Now, if P is false, what I will put in the box? I will put false. I will put false because that is false. So you can easily see that in this box I am putting P as it is. In this box I am putting P as it is. If P is true, I am putting true. If P is false, I am putting false. In this box I am putting P as it is. This is your answer. Let's quickly do this. Tell me the answer. F implies P. What should I write it? This actually, it is very simple. First of all, you already know false implies anything. False implies alpha. False implies alpha. That is true. False implies anything is true. But let's use this method. This you already know. This is method number 1. See, this is method 1. This you already know. Directly you know. But let's use this method. So in this box, what I should put? If P is true, what should I put? I should put true. If P is false, what should I put? I should put true. Whatever you do, I am putting what? Whatever you do, I am putting what? See, whatever you do, I am putting what? I am putting true. I am always putting true. I hope this method is getting more and more interesting. See this question. Let's see. False by implication P. What I should write? Don't take copy pen. Without copy pen, you do. False by implication P. Very simple. See. What should I put in this box? If P is true, I should put false. If P is false, I should put true. So the answer is what? Answer is I am putting P dash. I am putting negation P. Let me ask you one more question. P dash biconditional true. What is this answer? What is this one? This question? Twinkle, are you asking this question? False by implication. True. Are you asking this one? Is this done? Or do you have doubt? Okay, done. Okay, very good. Now tell me, what about this one? Now again, you can notice what should I put in this box? See. If this thing, if this thing is true, I will put a true. If this thing is false, I will put false. So this thing I am putting, do you agree with me? So this thing I am putting, please understand. Just call it this thing. This creature. So if this creature is true, I am putting true. If this creature is false, I am putting false. Whatever this creature is, I am putting that as it is. I am putting that as it is. Clear? I am putting that as it is. Understood? Understood? Now, are you confident that you will give me correct answer? Some students have given wrong answer. See. Okay, you can see some students have given wrong answer. See this again. Let me explain. Let me explain again. Just look at it one time. P dash biconditional true. What should be this? Let's call it some box. Now you tell me. Now, if this is true, then what should I put in this box? If this is true, then what should I put in this box? You know that true by implication true is true. So remember, if this is true, then I should put true. If this thing is false, then what should I put in this box? If this thing is false, then false by implication true, that is false. So I should put false. So tell me what I'm putting in this box. What I'm putting in this box? This thing I'm putting, right? This thing I'm putting in this box. Basically, I'm putting this thing I'm putting. I hope this point is clear. Okay, clear? Very simple things. Can you do it? Can you do this one? Let's quickly. P dash exclusive or false? Quickly. Don't take copy pen. Save some ink. Save paper. So again, you can notice this will be. Let's do this. See, I am also not taking copy pen. Okay, let me also do this in mind. So what is happening here? See this. I will not write. See, if this is false, then I should write false. If this is true, I should write true. So whatever is this, I will write that. So answer is P dash. Isn't it? Isn't it? Okay. See, if this is false, if this is false, then I will write false. If this is true, I will write true. I am writing this as it is. Let's do this quickly. Tell me the answer now. So very simple again. If this is false, I will write true. If this is true, I will write false. I am writing its opposite. I am writing its opposite. I am writing its opposite. Okay, understood? Let's do one more question. Just one more. Let's see P exclusive or P dash. P exclusive or P dash. See, they are always different. Do you agree? They are always different. P exclusive or P dash. If this is true, this will be false. If this is true, this will be false. So I will write true. If this is false, this will be true. I will write true. So whatever you do, it will be true. What about this one? P by conditional P dash. You can check it. They will be different. They will be different. They will always be different. This and this, they will always be different. So this is always false. Okay. So anyway, so this is the method. Now let's come back to our question. Come back to this question. This question. Now tell me. Okay. Now tell me. So in this, you can notice that if P is true, this is given to you, P is true. So here P is true. So if P is true, then this will be Q. Then this is going to be Q. So it will be like, I can say negation Q. But that's it. Now this negation Q, we don't know what is this negation Q. See, we don't know what this negation Q is. So we cannot say it is true. We cannot say it is false. Can I say it is multiple values? Can I say this is multiple values? Multiple values can never happen. A propositional variable can never have multiple values. I told you, a propositional variable, any propositional variable, or I can say any proposition you take, whatever proposition you take, either it will be true or it will be false. It can never have multiple values. It can never have multiple values. This multiple values can never have. It's like this. Let me give you the example. It is like this. You know that there is a student. You know either, okay, so this is some relative. This is some relative of yours. Okay, after many days, this relative comes to you and he says, oh, kitne bade ho gaye, pehchana. Okay, so what he will say? So he will say, pehchana, remember me. Now you are confused. Now you are confused. So is he like, okay, now you are confused. So let's assume this is some relative. Now you are confused whether he is Ram or Sham. Okay, now you are confused whether he is Ram or Sham. You are confused. So you are confused. You know that either he is Ram uncle or he is Sham uncle. But okay, you don't know. You don't really remember. But you know either he is Ram uncle or he is Sham uncle. Okay, or I can say Sham or Raju. So either it is Raju or it is Sham. Now tell me. You know Raju and Sham. So they are coming back. Hera Fairy 4 is coming. So anyway, okay, this is not a promotion of Hera Fairy 4. So anyway, so let's see this. So Sham and Raju. Now tell me, you are confused. You are confused. This relative is Raju or this relative is Sham? So tell me, can you say he has multiple names? So can you say, because you don't know his names, see, because you don't remember his name, so can you say his multiple names? Of course, no. You cannot say he has multiple names. I hope this point is clear. See, this is just analogy. I am telling you, proposition is either true or false. Proposition can never be both. This you already know. That proposition, any proposition, whatever proposition you take, any proposition is either true or it is false. It can never be both. One of them, exactly one of them, not both. Either it will be true or it will be false. It will be one of them. So finally, your answer will be what? Your answer will be what? You can say nothing about it. Okay, so you cannot say anything about negation Q. So this negation Q can be anything. It can be true or it can be false. You cannot say. So your answer will be option C. Is there anyone here who did option D during the homework 1 solution? When you were solving homework 1, did you do option D? Is there anyone? So now did you understand? Now did you understand? Tell me. Okay. So let's move on. I hope you understood. So we cannot say what is the truth value, but so we cannot determine. In this question, we have done so many questions. Now let's see. Let's move on quickly. This one, necessary and sufficient condition. That chapter, did you understand? Necessary condition, sufficient condition. That chapter, did you understand? Let me tell you, that is most confusing topic. Okay. If you understood, that is good. But let me tell you, for a normal student, that is very confusing topic. Okay. But I hope you understood. Are you confident? necessary condition, sufficient condition. I took many examples, many questions. Repeatedly, I was telling you, okay, because that is very important. You will use necessary condition, sufficient condition in operating system. In operating system, do you remember there is 4 necessary conditions for deadlock? 4 necessary conditions for deadlock. Why they are necessary? Now, next time you can say why they are necessary, why not sufficient? Okay, are you getting my point? Next time when you see 4 necessary conditions for deadlock, then you can immediately speak why necessary, why not sufficient. Okay, so you should understand now, in every subject you will use necessary condition, sufficient condition. In every subject you will use. Please understand. Okay, so this topic is important. So we have already seen this topic, necessary condition, sufficient condition. Now let's see this. Let's see if you can answer this question or not. X being a square, is it sufficient for it to be rectangle? Is it sufficient? If X is square, is it sufficient for it to be rectangle? Yes. If it is square, then for it's like this. Okay, it's like a game. You want rectangle. If I give you a square, are you happy? Is that sufficient for you? You want a rectangle. I give you this. Are you happy? Yes, you are happy. If I give you this, then also you are happy. So if I give you this, that is sufficient. That is enough for you. That is enough, right? That is enough for you. Sufficient means enough. See, you want a rectangle. Twinkle wants a rectangle. I give this square. Then Twinkle, is your requirement complete? You want rectangle, but this square, you have this square. Then this is enough. This is also rectangle. This square is also rectangle. Okay, so this square is also rectangle. So you cannot, this is enough. But is this necessary? Is this necessary? Like, you want rectangle and someone gives you square. Is that necessary? Is that necessary? This is not necessary. This is not necessary. For example, this is also done. This also can be done. So a square is necessary for rectangle. This is false. I hope this point is clear. So here actually that point is coming. P is sufficient for Q. How do we write this? How do we write this? P is sufficient for Q. And how do we write this? P is necessary for Q. So P is sufficient for Q. P is enough for Q. Means if P happens, then Q will definitely happen. Okay. P is sufficient. P is enough. Now you can notice that here, if P will happen, then Q will definitely happen. We have already seen this. So I will not go into the details of it. Okay. I am not going to go into the details of it. Now, this we have already seen in very detailed manner. Now, P is necessary for Q. P is necessary for Q. Okay, that means Q implies P. It is actually same as, see, P is necessary. It means without P, Q cannot happen. It means without P, Q cannot happen. It means if P does not happen, then Q does not happen. Okay, it means if P does not happen, then Q does not happen, and that is same as Q implies P. So this is Q implies P. And what is the best way? Someday, if you forget, someday, let's assume you are in the exam and you forget. You completely forget. Your mind is blank. Now tell me, then what is the best way? The best way is, see, if P is necessary, then who is sufficient? I told you these are dual. If P is necessary, then who is sufficient? Yes, Q is sufficient. Are very simple. All you have to remember that these are dual of each other. They are same. These two statements are same. These two statements, this statement, and this statement, they are same statement. They are exactly same statement. So again, you can notice that if P is necessary for Q, P is necessary, then Q is sufficient. So now this is your favorite. Q implies P. Okay, let's move on. Now let's see. Now tell me, X is rectangle. Is this sufficient for X square? Is this sufficient? If X is rectangle, then can I say it is a square? Sufficient condition goes in which direction? Sufficient goes in this direction. See, if x is rectangle, see, this is sufficient. This condition is sufficient. So this will go in the forward direction. Okay, but anyway, so you can notice if it is rectangle, can I say it is square? No, I cannot say. For example, this is not a square. Next, if x is rectangle, is this necessary, or necessary condition goes in which direction? Necessary condition. This is necessary condition. This goes in the backward direction. This you already know. Now tell me. So it means if it is square, then can I say it is rectangle? If it is square, can I say it is rectangle? Yes. Okay, here's something interesting. Can you see that these two statements are basically same? These two statements are basically same. X is square is sufficient for rectangle. It means rectangle is necessary for square, isn't it? So this is your square is sufficient for rectangle. X is sufficient for a rectangle. Then automatically what will happen? Then automatically you can notice that this rectangle will be sufficient for square. These two statements are same. Okay, so very easily. Now next, X is mother is sufficient. Sufficient means this direction. So mother implies female. That's true. Okay. Next, female implies mother. That is false. Female does not imply. If it is a female, it does not mean she is a mother. Okay. So you can notice. Next, female implies mother. That is also false. Next, mother implies female. That is true. So all these things you can easily see. Next, X is greater than 15. Is this enough? Does it imply X is greater than 15? Does it imply it is less than 20? Tell me. X is greater than 15. I give you some value greater than 15. Does it mean I have given you less than 20? Simple question. I give you something greater than 15. Does it mean I have given you less than 20? No. For example, I can give you 22. So again, this is false. What about this? X is greater than 15 is necessary for less than 20. You want less than 20. Is it necessary I give you greater than 15? Again, false. I can give you 10 also. I can give you 12 also. Simple thing. See, simple. So you can notice that. You can clearly see that. Or you can do like this. Or what you can do? See. Or what you can do like this. If X is less than 20, does it mean it is greater than 15? If X is less than 20, does it imply it is greater than 15? No. So you can do like this. Now, let's see. So I hope now these things are very clear. I hope. So again, you can notice X is less than 20. Does it imply sufficient? Sufficient means, does it imply X is greater than 15? Again, no. Next, X is less than 20. Oh, sorry, this is necessary. Necessary means this. Means X is greater than 15. Does it mean it is less than? Okay, so that is also false. X is less than 12. Does it mean it is less than 20? Yes, that is true. Yes, that is true. Right, this is true. Because if X is less than 12, then that implies it is less than 20. Okay, what about this? If X is less than 20, does it mean it is less than 12? This is false. For example, 8 is like, for example, I can say 15. 15. Akash, not 10. Akash, not 10. 15. Counter example is 15. Okay, this is another. If X is less than 20, does it mean it is less than 12? This is false. And if it is less than 12, does it mean it is less than 20? Yes, this is true. So these are your answers. Simple. Okay. Anyone has any doubt right now? So we are done with these questions. Now we will see some more questions, but at this point of time, do you have any doubt? In the necessary sufficient, do you have any doubt? After 5 years, 6 years also, can you explain? Can you teach this topic to anyone? Are you so confident? Tell me, are you confident in this topic? See, we have seen this topic in a very detailed way. You don't have to buy heart. Let me tell you, I have seen many students, they buy heart like this. They buy heart, they don't understand. P only if Q, they by heart. They will rote learn like this. They will do this rote learning. I have seen this, and the rote learning will be done like this, that this implies this. See, I also told you this trick, but before telling you this trick, did I tell you the exact logic? See, I also told you this trick. This trick I also told you, but before that, before telling you this trick, I told you the logic. And what is the logic? The logic is that P only if Q. What that means? Read this statement. P only if Q. So what do you think? Who is necessary here? What do you think? Who is necessary here? P happens only if Q happens. P happens. Read this. Read like this. P happens only if Q happens. Only if Q happens. Okay, it's like, some student is saying that I will go to the party only if my friend goes to the party, something like that. Sometimes people do this type of, I can say, people show some kind of stubbornness. Okay, so you can notice, I will go only if my friend goes. So who is necessary here? Who is necessary here? Just tell me. I will go to the party only if my friend goes to the party. So who is necessary here? So here, friend is necessary, right? So I can say that here Q is necessary for P. Here Q is necessary for P. Like, for example, I will go to the party only if my friend goes to the party. So for me, this Q is necessary. For P, Q is necessary. Understood? For P, for this to happen, this Q is necessary. Now it is a cakewalk. Now it is a cakewalk. Now this is your favorite. If Q is necessary, then who is sufficient? If Q is necessary, then who is sufficient? Q is necessary for P. It simply means P is sufficient for Q. And this is your favorite. P is enough for Q, means if P happens, then Q happens. So the logic, GoClasses is all about logic. Okay, is this clear? So you don't have to buy heart. We will also give you the tricks. These type of tricks we will also give you. But before that, we will tell you the logic. It will never happen that GoClasses is giving you some trick and you are feeling happy. See, it happens, I know. For a typical student, for an average student, if you give them the trick, they will feel very happy. It happens. Okay, you tell them the trick, you tell them the shortcut, they will feel very happy. We will not make you happy. Okay, see, our target is not to make you happy. Our target is to make you knowledgeable. Is this clear? Okay, for the entire year, our target is to make you understand. This is our target. We will make you understand everything very clearly with logic, with concept. So this trick is there, but the logic is beautiful. Once you understand, tell me which you will use in your life. This logic will you use or this trick will you use? I think this logic is also beautiful. Like, you can use it very immediately. You can use it, this logic. Okay, you can use it anytime. Okay, now let's see. So let's move on. Someone is asking some doubt in this. Is there anyone who was asking some doubt here? Please send your doubt again. Someone was asking some doubt here. Please send your doubt again. Whenever you put a doubt, you copy paste it. Okay, you put it on your Control C so that you can send it again immediately. Okay. So Twinkle is asking. Okay. Someone else is asking. X is rectangle is sufficient for square. So this statement, look at this statement. X is rectangle. This is the statement. X being a rectangle is sufficient for x being a square. This is false, right? This is false, correct? See, x is rectangle. X is rectangle. Does it imply x is square? Does it imply x is square? X is rectangle. Does it imply x is rectangle? Does it imply? Does it imply that x is square? This is false. This statement is false. Why? You can see this counter example. Let me give you this counter example. Consider this counter example. Understood? Okay. Anyone else? X being rectangle. So this statement is false. Is this clear, Himanshu? Please tell me. So this statement, see, x is rectangle, but it does not imply that it is square. See, this is rectangle. This is rectangle, but this does not mean that it is square. It is not a square. So if x is rectangle, does it imply that it will be square? Will it imply it will be square? Will it automatically imply? No, it will not imply, right? Is this clear? Okay. So there is a student who is asking, x wanting to do is sufficient for x doing. See, these are not mathematical statement. Please forget about them. That is the reason this do you remember? I gave you this, what is this is called? Disclaimer. I gave you this disclaimer. These are not mathematical statement. Forget about them. Doubt solver. Some student is asking, and his or her name is doubt solver. See, read this disclaimer. Please read this disclaimer. See. Please understand. Did you read this disclaimer? So only mathematical statement you worry about. Okay. Other than mathematical statement, do not worry about the answer. See, these are mathematical statement. I have only taken the mathematical statement. See, these are not mathematical. This mother and female, these are not mathematical. But these are mathematical. Rectangle, square, these are mathematical. So these four are mathematical. These two are mathematical. These are not mathematical. Mother, comma, female, these are not mathematical. Only care about mathematical statement. Okay. Is this clear? In mathematics, we don't worry about female. We don't worry about male, female, woman, man. Okay. Clear? So don't worry about non-mathematical statements. Okay. Let's move on. This is another question. Let's quickly see this. What is the answer? This is homework to question 2. And this question has been taken from this book. There is a Discrete Mathematics for Computer Science book by these authors. You can see Gary Haggard, John something, Shu Whitesides. Okay. So you can see. Okay. Now let's see. So finally, this is the question from this book. From this book, I have taken this question. Now let's see the answer. Now the question is saying, proposition P is true, proposition Q is false. What are the truth values of these? Proposition P is true. True or anything is true. Correct? True or anything is true. True or anything is true. So this will be true. It is going to be true. What about the second one? What about the second one? So this is going to be true. P is true, Q is false. P is true, Q is false. You know, true and false, that is false. So this is false. What about this? This is also false because negation P. Actually, one more thing. If you have this statement, what do you think? What does this mean? Does it mean like this? Or does it mean like this? Tell me. If you have this statement, this expression, what it means? What it means? It means the first or the second? It means the second, not the first. Okay, these are simple conventions. This is called convention, right? This is simply called convention, like, or I can say This is called priority. For example, in your mathematics, when I write like this, -2 multiplied by 3, what that it means? Actually, not this one, but -2 plus 5. Okay, what this means? Does it mean this or this? Like here, does it mean this one or does it mean this one? Which one it means? So it means this. It does not mean this. So again, you can notice these are called conventions. These are simple conventions. Okay. Anyway, we will see this order. But the point is that we give more priority to unary operator. This is the priority order. This is the priority order, preference order, precedence order. This is called precedence order. So we give more priority to negation. Then we give more priority to conjunction. Then we give disjunction. Okay. Then we give implication and then we give by implication. This is the order of priority. In mathematics, we have something called BODMAS rule, right? In mathematics, there is a rule, right? Precedence order rule, BODMAS or something. So anyway, so similarly here also, this is the order. Negation has the highest priority. So if you see this type of statement, if you see this type of statement, what this means actually? Tell me what this statement actually means. This statement actually means that first you will do the this negation P. Okay. Remember, this has more priority. Or has more priority than implication. So this or has more priority than implication. So this means this. Okay, clear? Very simple, right? Because implication has less priority than or. So this or has more priority. You cannot, this or has more priority. Okay, so remember this expression means this expression. So very simple. Anyway, now let's see this one. What is the answer for this one? What is the answer here? P and negation Q. Satyam is asking what about associativity? That I will teach. Satyam, don't worry. Okay, so what is the answer for this? P is true and so negation Q will be true, right? So true and true will be true. What about this? False implies true. That is true. What about this? False implies anything. That is true. What about this? True implies true. That is true. So the answer will be TFF, TTTT. Okay, let's move on. This is another question from the same book, Discrete Mathematics for Computer Science. Another question from the same book. You can easily solve it. P is true, Q is false, R is true. I think no one has any doubt. You can easily do this. P or Q or R. Okay, so what is that? P or Q or R. Actually, associativity I will teach, but you can easily see. True or anything is true. True or anything is true. What about this one? Again, true or anything is true. See. You don't have to calculate this. True or anything is true, right? Please understand. You can save some time. True or anything is true. You don't have to worry about it. You don't have to calculate this. You don't have to calculate this. True or anything is true. Next, true implies Q or R. Now Q or R is true. So true implies true is true. Next, you can notice this R is for this R is true. And what is this one? Q and negation P. So Q is false. False and anything is false. See, false and anything is false. Okay, so this is actually false. False by implication. False by implication true. That is false. So finally, this is going to be false. Okay, see, very simple. Now, what about this one? This is false, right? False implies anything is false. False implies anything. Anything is true. Sorry, true. False implies anything is true. Correct. False implies anything is true. Do you need to calculate this? Do you need to calculate this? You don't need to calculate. False implies anything is true. False implies whatever. Next. See. Next, you can see this is false. Okay, so what is this? P implies Q. True implies false. That is false. So false implies false. That is true. False implies false is true. Finally, see, this is true, right? Now tell me, anything implies true. What is that? Anything implies true. What is that? Anything implies true. That is true. So do you need to calculate this one? You don't need to calculate. So this will be simply true. Isn't it? See, very simple. This expression is true. So for anything implies true. Is it true? So these are actually useful. False implies anything. Is it true? And anything implies true. Anything implies true. Is it true? These are useful. Okay. These will be useful. Anyone has any doubt in this? Simple question, but anyone has any doubt, you ask. See, whether question is simple, question is hard, does not matter. Okay, if you have any doubt, please ask. Don't worry about easy or hard. This is another question. Let's quickly solve it. P, Q are two statements. Suppose P, Q are statements. P is this statement. Jack passed math. Q is this statement. Jill passed math. So translate into symbols. What will be the symbols? If you translate this English statement in symbol, what you will do? Jack and Jill. There is and here. Jack and Jill passed math. So it will be like P and Q. Jack passed math. Okay. And Jill passed math. So it is like Jack and Jill passed math. It means P and Q. Translate. If P then not Q. If P then not Q. If P then not Q, right? This question is not in the homework. I have taken it extra. I have taken this question extra, not in the homework. This question is not in the homework, Saswat. So please tell me the answer. Is this clear? If P, see, this is P. Jack passed math, that is P. Jack is passing math, that is P. Jill is not passing math, that is negation Q. Okay, so it will be P implies negation Q. So for this answer will be P implies negation Q. Okay, what about this? The next P or Q. It means Jack or Jill. At least one of them. It simply means either Jack is passing math or Jill is passing math. Jack is passing math or Jill is passing math, or both are passing math. Okay, Jack or Jill, you can say yes. Twinkle, you can say Jack or no, you cannot say Jack and Jill. This is Jack or Jill. You cannot say Jack and Jill. You can say at least one of them is passing math. At least one of them is passing. Okay, at least one of them is passing. Please understand. This is P or Q. It means at least one of them is passing. Both also is true. No, why both? At least one of them is passing. You cannot say and. You cannot say and. Maybe Jill is failing. Maybe Jill is passing, Jack is failing. Is this clear? Is this clear? In the option C. Let's assume the result comes. Please understand. Let's assume the result comes, and in the result this is written that Jill is passing or Jack is passing. Now, will they both be happy or tensed? This is the result comes, and this is written. IIT Kanpur gives this result. This is the gate result comes. Let's assume some result comes. Will they be happy or will they be sad or what? They will be confused. See, if this result comes, they will be both happy. Please understand. If this result comes, they will both be happy. Immediately, they will both happy. Immediately, they will both be happy. But here they will be confused. They cannot be happy. They cannot be sad. They are confused. They are thinking, who is passing? Either Jack is passing, at least one of them is passing. That is definitely. At least one of them is passing. That is definitely there. But can they both be happy immediately? I hope this point is clear. Let me know. Is this point clear there? The answer will be either Jack is passing or Jill is passing or both. At least one of them is passing. Okay, what about this one? Translate this statement. Option D. Option D is saying negation of P and Q implies Q. What that means? That means that this is if you can say that this is something like if. So it is like if it is not the case that both are passing, if see if then Jill passing. Q means Jill is passing. Okay. So this means Jill pass. So you can notice then Jill will pass. And what this means? This means it is not the case that both are passing. It is not the case that both pass. It means at least one fail. Yes or no? So he is basically saying if at least one is failing, then Jill is definitely passing. This is what the statement is saying. Do you agree? Please tell me, do you agree? See, this statement means it is not the case that both pass. It is not the case that both pass. It is not the case. It is not the case that both are passing. Means at least one of them is failing. I can say if one of them is failing, if at least one of them fail, then Jill will pass. Okay. So if at least one of them is failing, if at least one of them is failing, then Jill definitely will pass. Clear? Isn't it? Simple? It is simple. Let me know. Any doubt? Please tell me. Any doubt? So the statement will be this expression. This expression means this statement. Okay, this expression means this statement. So if at least one of them is failing, then Jill is passing. So this is another question. Very simple. Now let's see this one. This is interesting. Tell me the answer for this question. Suppose you know that if Jack is passing, then Jill is passing. So tell me what information you have in the logical form. What information you have? You have this information. You have this information, right? So you have this information. You know that this is true. What you know? You know that Jack implies Jill, basically P implies Q is true. You know that this is true. P implies Q is true. This is what you know, that this is true, right? Is this clear? The question is saying, suppose you know that this happens. Okay. Suppose you know that this happens. This information you have means you know that P implies Q is true. You know that this P implies Q, this is true. If you know this, then the question is saying, what can you conclude if you know that Jill is passing math? If Jill is passing math, can you conclude something? If Jill is passing math, see, simple. Okay. What is given to you? Tell me what is given to you? It is given to you that P implies Q is true. This is true. Correct? This is given to you. Now the first question is, if you know this Q is also true, the first question is, this Q is also not true, then what can you say about P? Tell me, then what can you say about P? Can you say something about P? What can you say? So you can see that, remember, if you know Q is true, see, P implies, if you know Q is true and the whole thing is true, can you say something about P? No. So from here you can easily see, from here P can be false also, P can be true also. P can be false also, P can be true also. We cannot say anything. So in this situation, we cannot say anything. Very simple. Can I say multiple values? Okay, tell me, can I say Jack will pass also, Jack will fail also? This is what multiple values means. Now are you getting multiple values what it means? Now are you getting this multiple values? Why that is wrong? Now are you getting? Can you say Jack is passing also, Jack is failing also? Can you say that? Can you say Jack has multiple values? It is passing also, it is failing also. So tell me, can I say P has multiple values? Now I hope you are getting that answer cannot be multiple values. You cannot say that Jack is passing and Jack is failing. You cannot say that. It's not Schrodinger's cat, right? Okay. Schrodinger's cat, that story I hope you know. Okay, cat is dead, cat is alive. So you can see, very simple. It is not Schrodinger's cat. Anyway, the point is simple that here we cannot say anything. That's it. So in this case, the answer will be, in this case, nothing can be said. Can't determine. What about the next one? Jill has not passed math. Jill is not passing math. Now tell me. So now it is given that Jill is not passing math. Now it is given that P is false. Q is false. Now it is given that Q is false. Now it is given that Q is false. Now tell me. Okay, that's it. See. Please understand. This is given. Please see. This is given, right? Do everyone agrees? This is given. That P implies Q is true. This is given. P implies Q. This P implies Q is true. This is given. Okay. Now, this is also given. Q is false. Now tell me. So what can you say? What can you say about P? What can you say about P? Something implies false is true. Automatically P must be false. P must be false, right? P must be false. Okay. So P must be false. So if Jill is failing, then Jack is failing. Okay. That is called the idiotic love. Right. Okay. If you go to jail, I will also go to jail. That is called the idiotic friendship. Okay. Bollywood friendship, but idiotic. Okay. So anyway, so you can see this is very simple. You jump, I jump. Idiotic things. Okay. Anyway, so yeah, Karan आएगा, Arjun आएगा. That's good. अगर Karan आएगा तो Arjun भी आएगा. Anyway, in this question you can see that you can say Jack fails. In this question you can say P is a false. It means Jack also fails. Okay, so this is what we can say in this case. Jack is failing. Okay, I hope these things are clear. Okay, so this question is actually quite simple. Now tell me, if I know that Jack is passing, then what can I say? If you know that Jack is passing, in this case, can you say something? Jack is passing. Then Jill is also passing. Then you can say Jill is also passing. So in this case, actually Q will be true. In this case, Jill is also passing. Okay. In this case, you cannot determine. This you can take as variation. This is called variation. Anyone has any doubt? In this variation, do you have any doubt? So I can call it variation. So is this question clear? This is clear, crystal clear. This question is taken from this book, Discrete Mathematics, an Open Introduction by Oscar Levin. I am collecting all the beautiful, good questions from many different resources. This is what we do in the Go classes. Okay, all the time. We will provide you standard questions from standard resources. So this is a simple question, but a good question. I hope you understood. Now let's see this one. Harsh is asking second option. Harsh, let's see. Are you asking about this one? Jack is not passing. See, what information is given? Harsh, can you tell me? What information is given? You just tell me what information is given. See, this information is given. Suppose you know that this information is given. Please understand. This information is given, hers. So what information is given? You tell me one by one. Let's go. Let's see this. So the given information is this, that P implies Q is true. This is true. This information is given. We have this information. Okay. Now you tell me, Jack did not pass math. So in the second option, see, first let's see the first option, then let's see the second option. In the first one, we are saying that Jack is passing math. In the first one, what that means? Jack is passing math. What that means, hers? Tell me. Jack is passing math. What that means? That means P is true given. P is true given in option 1. Okay. P is true. That is given. Correct. Now you can notice P true is given. P true is given. And this is given. From this, what can you say about Q? Can Q be false? Hers, can I put Q equal to false? If I put Q equal to false, then what will happen? If I put Q equal to false, then this will be false. So automatically means that Q is true. It means Jill pass. It means Jill pass. Similarly, let's see the second one. In the second one, what is given? In the second one, what is given? Jack did not pass. What it means? Let me know. Jack did not pass. What it means? It means negation. It means P is false. It means P is false. Jack did not pass. It means P is false. Given in second one. Okay. Now tell me. Now P is false. Implies Q. True. Now tell me, what can be Q? What can be Q? See, Q can be true or Q can be false. So we cannot determine Q, right? Q can be true or Q can be false. Q can be true or Q can be false. We cannot determine. So very simple. So in this case, you cannot determine. Any doubt? Anyone else? This is another beautiful question. In this question, what information is given? See, these are beautiful questions, let me tell you. And these are questions from this book. Okay. Some good questions from this book. Let's see this one. Cute questions. Yes, these are some cute questions from this standard book. Now let's see this one. Quickly tell me the answer. Determine whether these statements are true or false, or it is impossible to determine. Okay. Assume you do not know what is my favorite number. Okay. Molecular means compound. See, Satyam, molecular, atomic, molecular, like that. Atomic, compound, like that. Okay. You know, molecule, chemistry, atom creates molecules. So like that. Okay. Molecular means compound. Is this clear? So this is just a compound statement, some compound statements that are given to you. Okay. Now the question is saying, you do not know what is my favorite number, but you know that 13 is prime. But you know 13 is prime. So what information is given? Tell me which information is given. That 13 is prime. This is true. This information is given that this is true. This information is given. This information is given. Okay. This information is given. Now tell me. So remember, this information is given. So this is true, that is given. So I don't know what is this. Then true implies I don't know. What is that? True implies I don't know. What is that? I told you true implies Q. What is that? Tell me, true implies Q. What is that? We have already seen this. We have already seen this. True implies Q is Q. Your favorite method. What is that? Tell me which method you will apply. You can easily see. You can easily see. If Q is true, it will be true. If Q is false, it will be false. So you can see that. Now I can say that Q implies I don't know. What that will be? Q implies I don't know. What that will be? That will be I don't know. Q implies I don't know means I don't know. So finally your answer is what? True implies I don't know means I don't know. So please see this. Option A. This is true. 13 is prime. It is true. That is given. Okay, now let's see. So you can notice true implies this is I don't know, because the question is saying that you do not know what is my favorite number. So this is I don't know. True implies I don't know. That is nothing but I don't know. So here I can say that we cannot determine. So for this question, the answer will be I don't know. I don't know. Okay, what about the next? What about the next? See, this is true. I don't know implies true. What is that? Anything implies true is true. You know, anything implies true is true. See, you already know anything, anything implies true is true. So I don't know implies true is also true. So it means I don't know implies true is also true. So this second is true. What about the next? This is false. This is false. False implies anything is true. False implies anything is true. False implies anything. Is it true? Okay, what about the next? 13 is my favorite number, or this is true. Anything or true is true. Anything or true is true. What about the next? Is my favorite number and 13 is prime. Now tell me, P and Q, what is that? P and true, what is that? That is true. Sorry, that is P. P and true is P. It means what? I don't know and P. I don't know and true. What is that? I don't know and true. What is that? That is I don't know. Yes or no? I don't know and true. That is I don't know. So again here, the answer is unknown. I don't know. What about this one? 7 is my favorite number and 13 is not prime. This is false. False and anything is false. False and anything is false. False and anything. What about the next? 13 is my favorite number or 13 is not my favorite number. This is always true. This is last option is interesting. The last option is actually interesting. Right? This last option, that is actually interesting because see, please understand. I don't know what is this. I don't know what is this, but I know that this or P or negation P is true, right? See, please understand. I don't know what is this. So it's like I don't know or I don't know bar. It is like this. Okay, see the last option, the option number G. What is that? That is like this. I don't know or I don't know bar. I don't know bar. It is like P or P bar, and that is true. That is always true because they will always will be different. See, if P is true, then this will be false. That will be true. If P is true, then this will. If P is false, then this will be true. Negation P will be true, and it will be true. Simple. So this last option is a true. When you were solving this question, did you do this correctly? All the options, did you do correctly? Okay. See, one thing I want to tell you, this type of doubt I get many times. Sometimes GoClasses enrolled students, they ask this type of doubt that should I solve standard book questions? This doubt comes, right? Okay. See, this happens. Sometimes GoClasses enrolled students, they ask me this type of doubt, sir, should I solve standard book questions? Let me tell you the answer. The answer is this. The answer is, see, all the standard questions, that you need to solve for the GATE exam. Remember, in the standard book, there are many questions. Are all questions GATE relevant? In any standard book, there are many questions. Are all of them GATE relevant? No. What I'm telling you, all the standard questions that you need to solve for the GATE exam, we will provide you in our homework, in our weekly quizzes, in our practice set, in our test series. So you don't have to do anything from your side. You just have to study. You just have to solve the homework. You only have to solve the weekly quiz. You have to solve practice set, and you have to attempt test series. These things you need to do. Okay. All you need to do, just follow our course. Is this clear? Because every GATE relevant question, every GATE relevant standard question, we will put in these things. Clear? Okay. So this point I want to tell you. Oh, you only need to follow our course. This is one example. Did you notice? See, I have taken so many cute questions from the standard books. This is a standard book. From this, I have taken these questions. You can see in this homework too, so many standard questions I have already put. This is what I'm telling you, that each and every GATE relevant standard question we will give you in the homework, in the weekly quiz, in the test series, in the practice set. You only have to do this. Just follow our course. Second point, should I study standard resources? Should I study standard book? Again, the answer is this. Again, the answer is we are teaching you from many standard resources at the same time. Okay. From every subject, we are teaching you from many standard books. So remember, we are putting the screenshot also, right? When you see the lecture notes, we also give you the screenshot of standard books so that you can read, so that you can get confidence. Again, I am telling you, just follow our course. Is this clear? Because we follow standard resources. You follow our course. It's transitive. Okay, it's transitive. You follow us. We follow standard resources. Automatically means you are following standard resources. You are learning everything from standard resources. Okay. Sukhjit is asking, can I fully rely on GoClasses material for GATE 2024? And the answer is yes. The answer is yes in capitals, underline, bold. That is the answer. Okay, Sukhjit, that is the answer. Okay, so all you need to do, just follow our course, because we will teach you every subject from many standard resources, from many standard books. And we will put a screenshot of standard books in the slides so that you can read. So you don't have to do anything. You just have to follow our course consistently. From Grimaldi book, this is a discrete mathematics book by Grimaldi. Let me tell you, this book we follow in ISC Bangalore. Okay. So now you can do this, right? P, Q are primitive statement. What this means? What primitive statement means? What primitive statement means? That is like atomic statement. So P, Q are propositional variable. Agree? So these are propositional variable. These are propositional variable for which the implication is false. If this implication is false, what information you have? If this implication is false, what information you have? What information you have? Yes, this information you have that P is true, Q is false. P true, Q false. So this will be false. This will be P true, Q false. This will be false. This will be true. This will be false. And this is your homework. Okay. I hope you loved the homework. Okay. P and Q. Yeah, sorry, this P and Q will be false. So this will be false. So this first will be false. Okay, that's it. This is the solution of homework. So far, do you have any doubt, any confusion? Let's make sure that no doubt stays unresolved. Okay, no doubt stays unresolved.